Okay, Megan, we're on number 15. Oh, we gotta get further than 20. I'm hoping to get through like it'd be great if we could get through 29. That'd be awesome. Okay. 15 through 20 shouldn't take too terribly long, I hope. Number 15, a pilot in a plane at an altitude of 2,200 feet, or 22,000 feet. Here's my plane. Don't judge my plane. 22,000 feet means from there to the ground, to the ocean, to sea level, technically. Okay? And then I'm going to guess we've got something going on over here. So 22,000. Okay? Observes that an angle of depression to a nearby airport is 24 degrees. Okay, so here's my airport. Whatever. And the deal here is, though, when we talk about an angle of depression, it's from horizontal down, right? So angle of depression, here's what it's going to look like. Angle of depression is actually this guy is 24 degrees. Interesting. Interesting. Okay? Here's my airport. Airport. Okay? This says how many miles is the airport from the point on the ground directly below the plane. So what are we finding? How far is the airport from the point directly below the plane on the ground? Which side are we finding? I'll say that again. How many miles, here you go, you're fine. How many miles is the airport, which is this guy, from the point on the ground directly below the plane?
So we're finding
the bottom side. This is what X is. Okay, now we got to figure out an angle inside of our triangle, right? So we either need to find this angle or this angle, right? Which one do you want?
Let's find the top.
This guy right here, if this is 24 and like this, right? This would be 66 degrees, or this is 24 degrees, right? Because those would be alternate interior angles, right? Yeah? So either one. All right, now, since we have both angles labeled, we got to pick an angle. Do you want 66 or 24?
What do you mean? It's theta?
Yes, how's our angle theta? You want 24 as theta? Okay, perfect. Then we have this side, which is opposite, and we have this side, which is adjacent. We're just solving, right? So which trig function? O and A? Tangent? Okay, so we do tangent of 24 equals, which one goes on top? 22,000. And the bottom is X, right? And then when we solve for X, since X is the bottom, we flip those two, right? So we're doing 22,000 divided by tangent 24. Okay, and I don't know. It should end up being bigger than 22,000. No, hold on, just a second. Just wait. 24 degrees is opposite 22,000. 66 degrees, opposite way bigger, right? What do you got? 49,412 miles.
No,
feet. That would be like, so you couldn't be able to see that far. Oh, and then they want it in miles?
Yeah.
How many miles? So divide by 5280.
9.36.
9.36 miles. There we go. Good catch. I would have left it in feet. Good?
49,000 miles.
Now, could you have, given the fact that they wanted it in miles, could you have put this 22,000 in miles first?
Yeah.
Sure. Yeah, you could have. And then you wouldn't have to convert at the end. That's fine. All right. 16. Find the 6 trig ratios for angle theta whose terminal side passes through the point 6, -8. What quadrant is that in? 2.
Wait, 4.
I don't think so. 4. 6, -8. He's in the 4th quadrant. I'm going to draw him. 1, 2, 3, 4, 5, 6. Actually, 6, -8 is this point, like right here. Okay? So I'm going to draw, when it says the terminal side lives there, right? This is the point 6, -8. Okay, what shall we do with that now? I want the 6 trig functions. I want like sine of theta. I want cosine of theta. I want tangent of theta. I want cosecant of theta. I want secant of theta. And I want cotangent of theta. All right. Before we do that, let's make him into a triangle, shall we? Which way do you connect him? A bow tie, not an hourglass. So he's there. Okay, my sides are 6 and -8. Right? And 10. All right. Then we don't have to rationalize it all, right? Okay. So angle theta is here. Which one is the opposite? 8. Hypotenuse? 10. Adjacent? 6. Okay?
We don't put the negative on here,
We do. We do. Yes. Because otherwise he will not reflect that he's in the fourth quadrant. Okay, now here's the fancy thing. Sine is opposite hypotenuse. So negative 8 over 10, but we can reduce that to negative 4/5. All right, now here's what I'm going to do. Rather than writing them all out and having to reduce them, let's reduce them over here, shall we? Let's make this negative 4, let's make this 5, and let's make this 3. That's a 3, 4, 5 right triangle, right? Now, since they're reduced over there, I don't have to reduce them again over here. Got it? Okay, cosine is AH. So like 3/5. Tangent, OA, negative 4/3. And then you flip. Negative 5/4.
Kind of scared me.
5/3. Negative 3/4. Yep. Bless you, bless you.
Did you hear Otto sneeze and band today?
How about that? Does that make sense? Okay.
I like playing the instrument, but band itself makes me cringe. Like the fact that I played the band.
I don't like our band.
No, I don't like our band either. It's just
Okay, 17. What does this mean? Find the exact value of sine of negative 5 pi over 3. What does that even mean? What? No, because it won't give you the exact value if you plug it in.
It's the
Yeah, just look it on your unit circle. Where's negative 5 pi over 3 at? Oh, wait. You don't have any negative angles, right? So let's switch him to something. How do I make him better?
add 360.
Let's add 360, which is 2 pi, because we're in radians, right? If I add 2 pi, that would be like adding 6 pi over 3, right? What's negative 5 pi over 3 plus 6 pi over 3? 1 pi over 3. Okay, so I want to actually find sine of pi over 3 and not sine of negative 5 pi over 3. Because they are the same place, okay? Pi over 3 is in the first quadrant. It's 60 degrees, and sine of 60 degrees is the y coordinate. So it's just asking for whatever the y coordinate is. You said square root of 3 over 2? Square root of 3 over 2. Final answer. Okay? When it says exact value, don't do a decimal.
That's what I said.
Yep. You want just to look it up on the chart. Awesome. Yep, that's the answer. Square root of 3 over 2. Did you guess that?
No, I just looked at 5 over 3, and the sign was already negative, and then you just
Yeah.
another negative to make
Yeah,
it.
kind of, yeah. Yeah, exactly. Perfect. Look at you go. Awesome.
every bit of
Yes, but cosine is different. So cosine, if it's negative, it stays negative.
Okay.
Yes. Because he has different, like, his signage is weird. Okay? All right? In what quadrant? So we only have 4 answers. You have a 25% chance of getting this one right. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Does angle T lie if cosine is negative? Okay, cosine is which one, x or y? Cosine is the x coordinate. So cosine is negative, so this is a negative. And tangent is positive. Okay, how do you find tangent?
One.
Tangent is, no, it shouldn't be quadrant 1. Tangent is sine divided by cosine, okay? But if cosine we already know is negative, what does sine have to be in order for tangent to be positive? Okay? Tangent is sine over cosine, but we already know that cosine is negative, so what does sine have to be in order for tangent to be positive? It has to be negative. So I want to know what quadrant we have a negative and another negative in. Which quadrant is negative x and negative y? Negative x goes this way, negative y goes this way. Quadrant 3.
Oh, I was thinking
Only tangent being positive. Yeah. There's only 2 quadrants where tangent is positive. It is the first one and the third one. But which one has cosine that's negative? The third one. Got it? Yeah, not too bad. Okay, express this as a single real number. All right, we have 3 pieces. We have sine of pi over 2, sine of 0, cosine of 0. This is look the thingy up on your unit circle. What is sine of pi over 2? Pi over 2 is 90 degrees. Sine is the y coordinate. 1. Okay, what is sine of 0? 0. What's cosine of 0? So the answer is 2. Look at that. Let's give us some of those, right? Okay, 20. I'm just going to get him ready. Let's get ready to draw him. If pi over 2 is less than t is less than pi, what does this even say?
It's in the second.
It's in the second quadrant, right? Pi over 2 lives here, pi lives here, so we know we're in the second quadrant. I'm going to draw a triangle. Okay, angle theta is here. Or they call it angle T, actually, is the name of him, because it's cosine of T. Okay, all right, then they give me this piece of information. Cosine is negative 12 over 13. How does that help me?
So, okay, wait, so cosine is opposite,
Nope.
no, adjacent hypotenuse.
Cosine is adjacent hypotenuse. So the adjacent side is 12. Which one's the adjacent side? The bottom is 12. The hypotenuse is 13. Which one is negative? 12. Okay, what's the other one?
Oh, man.
You know this. 12, 13. 12, 13. 5. Okay, now, is the 5 positive 5 or negative 5? Positive, because he's going up, right? Okay, so that's what I label, and then I want to find sine of t, right? So sine is OH,
Negative 5 over 13. Positive 5 over
positive 5 over 13. That's all. Got it? Got it, got it, got it, got it. Okay, beautiful. Do these like kind of ring a bell a little bit? Yeah, yeah. Okay, reference angles. Let's do A together and let's see what we get. Reference angle. I'm going to draw a picture of where this guy lives. 135, where does he live? He lives in the second quadrant. Okay, so like this is 135 degrees. But your reference angle, when they ask for a reference angle, they're asking for the bow tie angle, right? That's what a reference angle is. It's the acute angle, right? So what are we looking for? We're looking for,
to 90 or
if I make him into the bow tie, what is this angle right here? You see that? So in this case, since we're in quadrant 2, 180 would be this whole thing, right? That's 180. Minus 135 would give me this little guy. Is that 45?
Yeah.
45 degrees is his reference angle. Does that make sense? The reference angle is like find the little bow tie angle. Okay. All right. Good, good. B. How do you do B?
Subtract 360.
Let's subtract 360 first to get him down lower, right? And that would be how much? 300 degrees, okay? Where does 300 degrees live? In the fourth quadrant, right? So 300 degrees would be from here to here. That's 300. I want the bow tie angle, right? So that is like this guy right here. So how much would this angle have to be in order for him to like complete the rest of the way? 60 degrees is your reference angle. Your reference angle is never negative. Always positive.
Make our whole test over these.
Yeah. Okay, what about C?
Wait, add.
Let's add 360 to get him positive. Okay, which makes him 30 degrees. 30 degrees is in the first quadrant. He would be like this much, 30 degrees. Okay, what's his reference angle?
30.
Reference angle is the bow tie angle. He's already a bow tie. If he's in the first quadrant, he is his own reference angle. Yep, in the first quadrant, you don't have to do anything. He's already his own reference angle. Okay,
Is that
D?
the same with fourth?
No,
Or third, I mean?
no. Third is just, third you subtract 180, and that gives you the reference angle. Like let's say 200 degrees, right? 200 degrees here. 200 degrees would be 20 as a reference angle. Does that make sense? Okay, that's not the correct thing. Okay, negative 690. What shall we do?
Add 720.
Yeah, we could add 720, which is like 2 units of 360, okay? And that would be 30 degrees. Well, that's fancy. Again. Whoop. 30 degrees. He is his own reference angle, so 30 degrees. Got it? Happy with that? Yeah, yeah? Okay. All right. Keep going. Okay, graph. Here we are just graphing regular sine, regular cosine, regular tangent. Got it? Except we are graphing him from negative 3 pi to positive 3 pi.
So like
All right, so normally sine, one period is from what to what? 0 to 2 pi. Let's just start with that. Okay, I'm going to put 2 pi here. And I'm going to put 1 pi here. And then we got to go out to 3 pi, but we're going to get to that, right? Okay, so just focus on like here to here for right now, right? Okay? I'm going to put my other little markings in there. You don't necessarily have to label them, whatever. How high does sine go? 1, and low is -1. Okay? Where does he start? He starts at 0. Here he goes. Up, down, down, up. He does one of these. Okay? He does that. That's what 1 period of sine is. Now, they want us to continue him and do from -3 pi to +3 pi. Okay? So, if we finish him out and graph this little bit of him, he'll just be another little hump, right? We just got to keep doing another little hump, right? Okay? And if we go to -3 pi, I'm going to do the same units. So this is -1 pi. This is -2 pi. This is -3 pi. I'm going to do my little humps right here. Right there. There's one hump. There's another one. And there's another one. And that is going from -3 pi to +3 pi. Got it? Happy with that? So we didn't change him at all. Like we didn't stretch him out, make him taller, nothing like that. We just graphed a wider group of him than we're normally used to, which is fine. So the red one is 1 period. This guy right here is 1 period. We just extended it out and made it longer so we could see more of it. Okay, good. 23 is the same thing, but with cosine this time. All right, so let's graph 1 period first. And 1 period goes to 2 pi. So I'm going to put my labels here, but just leave enough room so that you can slide 3 pi in there. So 1 pi, 2 pi, I'll put 3 pi here. We'll focus on him later. But cosine, we're just going to graph him from here to here, right? Just that little chunk. He goes as high as 1 and as low as -1. Okay? He starts.
All that for a chocolate bar.
Chocolate.
He starts where?
1.
At 1. And he goes down and up, and he makes like a little V, like a cursive V kind of. Okay, that's what 1 period looks like, right? But then we're gonna graph 1 more period, right? So he's gonna come back down, he's gonna hit here and then go back, right? Oh, I should graph him in another color. Okay, so there's finishing him out to 3 pi.
You don't know my mom's maiden name?
I feel like I've heard it.
Is it with a K?
Yeah.
Yeah. But I don't know how to say it.
Boon.
Try and spell it.
Cleaver.
Yeah, somewhere. I don't know how to spell it.
Kawasaki.
That's right.
Kiminau.
What are you?
Kawasaki.
That's not how you say it.
What is your mom's maiden
What is
name?
it?
Kiminau.
Who are you?
Kamanu?
Your mom was a Kimina?
Yeah.
Really?
How do you say it so quick?
I didn't know that.
Ethan, your mom.
Is she related to the Kiminas in Lawrence?
Well, actually, maybe.
All of them.
Because my grandpa.
Like Mary Kimina, Amanda Kimina that died when she was in high school or whatever?
Maybe, because my grandpa did go to Lawrence.
Okay.
So I don't know. if
So
there's-
distantly probably, yeah.
Yeah.
Nice.
Hold on.
Yeah, but
'Kay.
She went to
Hold on.
Donovan
Hold on.
Trumbull, so.
I
Gotcha.
bet you don't. I bet I
You
do.
don't know what my mom's middle name
I bet I
is.
do.
Her maiden. No, middle.
Amanda Kimina was in my grade in school, and she died. She died the morning that we lost the state championship in football.
Ooh.
So we went to the state championship, and my best friend who went to school with her up until 8th grade was like bawling after the game, and everybody's like, "It's okay, like we'll get him next year, whatever." And she's like, "I'm not crying because we lost the game." Like she was on her way to 1-act practice and was late one morning and drove off the gravel road into a huge drop off. It was really bad,
Graham.
really bad.
No!
Okay, did you get cosine filled out? All the way through. So the red one is the first period, but then you keep going from -3 pi to +3 pi. Did you get him done? Done?
Yep.
Yep. All drawn? Okay, tangent. Okay, what does tangent look like? Do we remember?
It's the
Tangent has.
It's like an S. It's like
I've never seen it before.
Yeah, kind of. Yeah. He has vertical asymptotes at where?
negative.
First of all,
pi over
what's
2.
the period of tangent, by the way?
1 pi.
1 pi, right? So if we split him, and he's 1 pi from here to here, right? 1 pi. He will be a half of a pi on either side, right? Okay, so pi over 2 goes here, and negative pi over 2 goes here, right? And those are my vertical asymptotes.
I don't even know what it is. Yes, I do.
Okay? That's what he looks like. Pi over 2, negative pi over 2.
What's your mom's name?
Okay. Now, real quick. Pi over 2 is my vertical asymptote there. Where will the next vertical asymptote hit? There's pi in between. So if I add pi to pi over 2,
Pi over 2, 3 pi over 2.
he'll be at 3 pi over 2,
What?
right? And that's where my next vertical asymptote will be.
Eye roll.
And again, at
You were like,
Negative pi over 2.
negative 3 pi over 2. That's where another vertical asymptote will be, okay? And he goes like, whoop. Oh, I guess I should. If we go here at 1 and here at negative 1, right there will be there, and right there will be there. La, 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 something like that, something like that, right? Oh, gosh.
All right, buddy.
Actually,
How's that?
Camilla, let's see your maiden name.
So it's actually 3 periods of tangent. What? My
I know
maiden
it- I
name?
know what it is.
My maiden name is such an easy maiden name. I went from a easy name to like a super hard name. It's terrible. But I still had people ask me how to spell it. When I would call and make doctor's appointments, I would say Emily Lovejoy, and they were like, "How do you spell that?" I said, "It's spelled like it sounds.
Remington's mom's maiden name is
Lovejoy.
Why do you know that information?
Fletcher is your mom's maiden name? Fletcher. I think Fletcher is kind of a fun first name. You should have been named Fletcher, Remington. Don't you think Remington makes a good Fletcher?
Fletcher Johnson.
Fletcher Johnson.
What's your Johnson?
Like I've heard the first name of a little boy, like a baby boy, like Fletcher. Yeah.
I'm not an
that'd
arrow
be kind of fun.
maker, so-
Like the different
You're not what?
I'm not an arrow maker. So.
Oh, okay. Is that what it means?
I was
Arrow
gonna
maker?
say like
A
Fletcher?
Fletcher is someone who makes
fletching
arrows.
is like
Interesting.
the thing on the-
Okay. Okay. All right. There we go. Good. Tangent. All right. 25. ABC. Find the exact values. Again, that means no decimals. No decimals. There should be more than one for which the given statement is true. So when it says sine of t equals -1, where on your unit circle is sine -1?
At 90 degrees. So pi over 2.
At pi over 2, is that the only place? No, it should be pi over 2.
Oh,
It should be
-1.
3 pi over 2 or 270 degrees. Is that the only place that sine is -1?
Over 4. No, that's me.
You are cooked.
Yes.
Yes. Okay, so that's A. B. Where is tangent square root of 3?
You're the one that said it.
Where is tangent equal to the square root of 3? Yeah?
It's gonna shut off.
No, it's not. Oh, I don't know why it does that.
4 pi over 3 and pi over 3.
4 pi over 3
And pi over 3.
and pi over 3. Those are the two places. And 4 pi over 3 is,
270. I lied.
no,
240.
240 degrees. And pi over 3 is 60 degrees.
Do we have to put it in degrees and radians?
I don't care. It doesn't say, so I will take either. But I'm putting both of them on your review. Right? Right? Okay, now, here's my question. Ready?
We get to
Hold
use our
up.
unit circle, right?
Yes, absolutely. Okay, here's my question. Hold up. Let's say this was worded ever so slightly different, and they said t is equal to inverse tangent of the square root of 3. What if like those two are saying basically the same thing, but if they word it like this, there is only one answer, and that one answer is which one? only 60 degrees, okay? So, because inverse tangent will only give you one answer. Tangent is the square root of 3 at 240 and at 60, but inverse tangent will only yield 60 degrees because that's the only one that's in the domain. Okay, cosine. Where is cosine squared of 2 over 2?
Cosine.
Pi over 4 and 7 pi over 4, which is 40 degrees, or 45, excuse me, 45 degrees and 315. Is that true?
I think so.
Yep.
Yeah.
Yeah. Yeah. How about that? Good?
How about them apples?
Okay. State the domain and range of tangent of 2t. What does the 2 do?
It makes it taller. Yeah. Makes it wider.
That's 2 tangent of t. What's the 2 do?
No.
Makes it wider.
Is the 2 an A, a B, or C, or a D?
A B.
That's a B. What's a B do?
Taller.
No.
Wider. Not taller. Is it not wider?
B changes the period. What's the period of tangent already?
2 pi.
1 pi.
1.
Okay, so how do I find the new period?
B. No. 1 pi over B.
1 pi over B, which is equal to 1 pi over 2.
Oh, so it makes it shorter.
So it makes it shorter, right? So now, if I think about the graph of tangent, before he was 1 pi. Shh, shh,
She's crying.
shh. Why is she crying? Why is she crying?
Stupid.
Oh my lord. Okay. Before he was 1 pi, now he is pi over 2. So if there is pi over 2 in between these two, if there's a half of a pi, where is the vertical asymptote here, and where's the vertical asymptote there?
4th pi negative 1/4.
Pi over 4 and negative pi over 4. Yeah? Okay. So, state the domain and range. Let's start with range. Up and down.
Infinite. Infinite.
All rails. Domain.
Negative pi over 4 pi over 4.
He is all reals except,
Parentheses.
I'm going to say except pi over 4 plus, when will his next vertical asymptote be? How much after pi over 4 is his next va?
3 pi.
No, no. When is his next, how much is in between his asymptotes? Pi over 4 is his first asymptote. How far in between? How much do I have to add to pi over 4 for his next asymptote? Pi over 2. Because that's the period, right? So, except pi over 4 plus pi over 2, okay. Right? Any interval of pi over 2 after pi over 4 is where he will have a vertical asymptote. That's a little bit difficult. Yeah, yeah? Yeah, yeah?
Wait a dang minute.
Wait a dang second. Okay.
I'm very tired.
Okay. What time do we get out of here?
Not soon enough.
Oh, yeah. We're going to get done with these 3. We really are.
36. I'm hungry.
Wait.
Oh, that would be really nice if we went to lunch after this. You know that? That would be really nice if we went to lunch after this. It would be nice, I'm saying.
To have lunch after.
We'll have lunch after this.
That's what I was saying. 1, 2, 3, 4, lunch, 5, 6, 7, 8.
Yeah, but then I feel like my afternoon would just be like really super long. I don't know. That's what the junior high
They
does.
have shorter classes.
No,
Shorter than.
I don't know.
The afternoon
I don't know.
classes will
'Kay.
be shorter.
Yeah,
Or
we
no,
can, we
no.
can,
All right, ready for
we can get
27?
lunch- We can get lunch earlier because you have 4 classes instead of 3, so it has to be shorter.
They want to
You
know
get lunch an hour.
amplitude. They want to know period. They want to know phase shift. They want to know vertical shift. This is all the stuff that we usually write down before we graph him anyway, but we don't have to graph him. They just want to know the things, right? Okay? All right, so the negative is not one of these parts. Did you know that? The negative does not do one of these things. The negative does his own special thing, which is,
I apologize for the interruption. There has been a medium-sized black dog with white chest and some gray whiskers on its snout at the school today. If you think this might be your dog or know whose it might be, please come to the office.
Oh,
That's crazy.
whose dog is it?
And it's probably the
Looking at
one in
me.
that big house Like
I wasn't
right
looking
here.
at you. I was
trying
trying
to
to
People
face. Oh.
Medium
I just
size?
seen it on here the other day.
I don't know.
Well, that's not the same dog that we use.
That's not the mean one.
Okay. All right. So the negative is what flips him over the x-axis. That negative does nothing of these 4 things. Okay. All right. Now 2 is a what? A, B, C, or D? That's a B. What's 5?
C. No, D.
D. Okay. So as far as amplitude goes, amplitude has to do with A. Do we have an amplitude?
1.
Because we don't have an A. Yeah, it's 1, right? So amplitude is 1. Okay. I always do amplitude and then I do the D part. What's D? Vertical shift.
Plus 5.
Up 5. You could put plus 5 and I'd count it, right? So up 5, plus 5, one of those two. Okay. Now we get to the hard part. Period is,
2 pi over.
maybe put this down right here. Here's the formulas. 2 pi over B, and for phase shift, it's negative C over B. Put those down in case you need them. There they are. So 2 pi divided by B, and B is 2. So the period now is pi. We made him shorter, right? Amplitude 1, period is pi, vertical shift is up 5. What's the phase shift? None. There's nothing because we don't have a C value. That's super nice. Okay? If an equation fails to have an A or a B, it will still have an amplitude or a period. Does that make sense? Even if he doesn't have an A value, he will still have an amplitude. Even if he doesn't have a B value, he'll still have a period. It'll just be 2 pi and 1, right? Okay? How about that? That's it. That's all they ask for. Okay, let's do number 29 first, and let's come back to 28. 28 is kind of a little difficult. Okay, let's do 29 first, okay? Cotangent of 2t. The 2 is A, B, C, or D. Which one?
B.
B. Cotangent has a B. And B affects the period, and the period is, for cotangent, is pi over B, right? But now it's pi over 2. Okay, cotangent normally, if you want to sketch him, he's also on the back of your unit circle. Cotangent starts at 0, has a vertical asymptote there, and he ends over here at pi, right? Because cotangent's period is pi. But now I make him smaller, and now his period is pi over 2. So how does that work? Will his vertical asymptote still be at 0?
Oh, cotangent. No, it's at.
Oh, cotangent goes this way.
Well, it's still at 0, but it's at half.
It's at 0, but over here, it's not at pi, right? It's at pi over 2. So he's skinnier, like that. Okay? What's this halfway point right here?
1
Pi over 4. And he goes like this. Like that.
You're so late on it.
Okay?
Go blow
There
your nose.
is
There's
that.
tissues back there.
Pi over 4. Pi over 4. How is that? Good? Okay, we got one more. I told you we were going to get through 29 today. You didn't believe me. And we got one more tomorrow. Perfect. 20. We got to go through 28 now. Okay.
You're like 6 months late on the Sigma board.
All right. This is the hard part. 28. Are we ready? Last problem. Last problem. We need to work backwards. And we got to take these guys and we got to put them into this thing. Okay? So I'm going to leave room for an A,
Oh, this isn't gonna be that bad, is it?
No.
a B, which goes in front of the T, a C, and a D. There's A, B, C, D. And we'll put F of T here. Okay? Equals. All right. I know for certain that what goes where?
Amplitude 4.
Amplitude 4 goes here. Okay? And
Vertical shift is plus 6.
D is plus 6. Okay? The other two I have to work a little bit harder for. Okay? If I want the period to be 4 pi,
1 over 2. Because you divide by.
you're just all the things. Okay? Normally, we take 2 pi. Actually, we always, you're doing mental math, and like some people can't do mental math. So 2 pi, we take 2 pi and divide by B to get the period, that they're giving me the period, right? Normally, we have B and we're trying to figure out what that is, right? So how do I solve for B if that's the thing, right? How do I like work backwards? I'm gonna switch places. So 2 pi over 4 pi will give me what the b value is, right? The pi's cancel. 2 over 4 is 1/2, so b is 1/2, right? 1/2 goes there.
If it was pi over 2, it would be 4.
It would be 2.
Did I ask Remington?
No, the period.
Oh, right. It would be 4. Yeah.
You Sigma.
Yeah. Because smaller numbers make bigger periods, bigger numbers make smaller periods. It's inverse. Woo! We're gonna run out of that before the last problem. All right, now this is the hardest one. How do you find, like, what gives you the phase shift? How do you find phase shift?
Is it negative b over c?
Phase shift is negative c over b.
C over b.
Okay, will give me the phase shift, but I know the phase shift is what?
Pi.
Pi, right? They say to the right pi, so negative c over b is pi.
So 1/2.
Okay, but we know that b is 1/2, right? Okay, so how do I figure out what c is? Negative c over b will give me pi.
Times 1/2. Times half.
I'm trying to find c, so I'm going to get rid of this 1/2, right? I'm going to multiply by 1/2 to the other side. But also, can I multiply by the negative 1/2
Yeah.
times negative 1/2
So,
to the other side?
yeah, negative
So
pi
c will be equal to, what's pi times negative 1/2? Negative
over,
pi over 2. Negative pi over 2. You see how we worked backwards? We said negative c over b is equal to this, or pi over 2, or 2 pi over b is equal to this, right? And then we plug them back in. If I were you, and this was a test question, I would then plug those in and find the period from there to make sure it checks out, right? But that is your thing, right?
Sigma, ligma.
Alrighty
There you go.
then. Name the movie.
Alrighty then.
Whew. Okay. All right. That was a lot. We did a lot today, didn't we? All right. Goodbye, Megan.
Watch the